Evening all. Today we have questions from P block elements. We are doing those questions from last 5 or 6 days. So on the same line, today we have question number 18 onwards of NCERT exercise of P block elements. So first question is, why is dioxygen gas but sulfur is a solid? So why dioxygen is a gas? Because first of all, oxygen is small in size. So as oxygen is small in size and it has ability to form strong p-pi bond. It has ability to form strong p-pi bond. So as it has ability to form strong p-pi bond, so oxygen exists as O2. Oxygen gas exists as O2, and molecular mass of O2 is very less. So there are weak van der Waals attraction between O2 molecules. So इसलिए oxygen exists as dioxygen exists as a gas, but sulfur, it is large in size. So as sulfur is large in size, so sulfur that cannot form strong p-pi bond. So as sulfur is not able to form strong p-pi bond, but sulfur single bond is stronger than oxygen single bond. That's why sulfur exists as S8, puckered ring structures of S8. Okay, and being large in size and higher molecular mass, there are strong van der Waals forces of attraction. That's why sulfur exists as a solid. So this is question number 18. Now come to question number 19. Knowing the electron gain enthalpy values of O to O negative and O negative to O2 negative. See, O to O negative has minus 141 electron gain enthalpy, and for O negative to O2 negative, it is plus 702 kilojoule per mole. So how can you account for the formation of large number of oxides having O2 negative ion species and not O negative species? This is the question. Now see, from O to O negative, energy is released. That means this reaction should be more favorable. But O negative to O2 negative, large amount of energy is absorbed. So this should be less favorable as per the energy values. But there are large number of oxides in which oxidation number of oxygen is 2, minus 2. So why is it so? This is the question. So simple ways, just compare, when oxide is formed, there is a formation of solid. There is a formation of solid, and therefore there is a concept of lattice energy that comes into picture. Lattice energy. See, let's have metal with 2 plus charge. So metal first forms M plus electron, okay, M to M plus electron, then M plus to give M2 plus electron, Now see here, energy released is, sorry, energy absorbed is first ionization energy and second ionization energy. That is, energy is absorbed here, because energy is required to remove the electron. Now come to oxygen. O to O negative, energy is negative, that is minus. First electron gain enthalpy is minus 141 kilojoule per mole, and second electron gain enthalpy, one electron is added, so second electron gain enthalpy is plus 702 kilojoule per mole. So overall here also energy is absorbed. If we form O2 negative, then overall energy is absorbed, right? But when M2 plus gets attached to O negative, then it will give MO2, and when M2 plus is attached to O2 negative, we get MO. So in this case, there is a low lattice enthalpy. Here there is a high lattice enthalpy. That means this huge amount of higher amount of lattice energy released during the formation of oxide in 2 negative state, that will compensate the energy absorbed at this stage. To convert O negative into O2 negative, energy is absorbed, but that energy absorbed is less than energy released when O2 negative ion attached to the metal ion. Got it? Means lattice enthalpy is dominating over lattice enthalpy of metal oxide in O2 negative state is dominating over lattice enthalpy of metal oxide is dominating over positive electron gain enthalpy. What is lattice enthalpy? It is the amount of energy released when 1 mole of oxide, metal oxide, is formed from its constituent gaseous ions. Okay, so ionization enthalpy, that is also in gaseous state. Electron gain enthalpy, that is also in isolated gaseous atom. So when these isolated gaseous ions combine to give oxide, that is in solid state, there is a concept of lattice energy, and that lattice energy is released. Amount of energy released when 1 mole of metal oxide is formed from its constituent gaseous ions. So the energy released during the formation of metal oxide in 2 negative state is very much higher than in the -1 state, and that huge amount of energy released compensate the energy absorbed at this stage from O negative to O2 negative. That's why most of the oxide are in the form of 2 negative rather than 1 negative. Yes, beta. Any doubt in it? I think it's clear to you. Got it? Why oxides in -2 states are dominating over 1 negative state, and there are rarely any oxide in one negative state. Done. Question number 20. Which aerosols deplete ozone? This is a general question. You have done this type of question in class 11 as well, in environmental science, environmental chemistry, last chapter of class 11. Yes, beta, tell me. Which aerosols deplete ozone? Name one aerosol. Only one. Yes, beta. Fast. Which aerosol deplete ozone? Hmm? Fast, beta. Very good. It is chlorofluorocarbons. So, CFCs deplete ozone. For example, especially freon. They are called freons like CCl2, F2. So, in CCl2, CF2, Cl2, first of all, there is a formation of free radical. Now, this free radical, chlorine free radical, gets attached to oxygen to give ClO, sorry, it depletes ozone into O2. So, one of the oxygen of ozone attached to chlorine free radical to give oxychloride free radical along with O2. Then this oxychloride free radical further react with ozone to give Cl free radical along with 2O2. Okay. So in this way, whole of the ozone is converted into O2, or even ClO free radical give rise to chlorine free radical and oxygen free radical back, and therefore chlorine free radical again attached to ozone, or oxygen free radical again attached to ozone to give O2, right? So chlorofluorocarbons are used to sorry, okay, or even this free radical gets attached to another oxygen free radical to give chlorine free radical back and O2 gas. So in this way, ozone is depleted, or ozone is converted back into oxygen. So chlorofluorocarbons are used for that purpose. Done. Next. Okay, next question is describe the manufacture of H2SO4 by contact process. Say like ammonia is prepared by Haber's process, nitric acid is prepared by Ostwald process. On the same line, sulfuric acid is produced or manufactured by contact process. So in this case, step 1 is sulfur is bond in excess of oxygen and we get SO2 gas. Sulfur bonds in excess of oxygen to give sulfur dioxide gas. So we use sulfur burner where sulfurs are in the tray and we heat it in the excess of air and we get SO2 gas. Okay. Step 2 is most important in this process, in which SO2 gas further, say first it is purified, we remove acidic impurities, okay, even dust from the mixture, and that's dry SO2 because we pass it through concentrated H2SO4 first. So SO2 gas is converted into SO3 gas in the presence of vanadium pentoxide. This is heterogeneous equilibrium. SO2 in the presence of oxygen, we get SO3. This is the key step. So temperature, so keep in mind, because this reaction is exothermic, but low temperature make the reaction slow. Why? Because O2, there is a double bond between oxygen atoms, and therefore very low temperature it cannot break at very low temperature. That's why optimum temperature is required. So first is low temperature, but very low temperature make the reaction slow. So we write it as optimum temperature. So optimum temperature is required of the order of 700 Kelvin. Second, pressure. So high pressure, because according to Lich-Rayleigh's principle, high pressure favor that side of the reaction where gaseous moles are less. High pressure favors that side of the reaction where gaseous moles are less. So see, on the reactant side there are 3 gaseous moles, 2 SO2 and 1 O2. On the product side there are 2 SO3, 2 moles of gas. So product side is favored at a high pressure. So high pressure is required. And third is presence of catalyst. So here catalyst used is P2O5, right? Then after the formation of SO3, this SO3 is not directly taken into water, okay, because then it gives H2SO4, but reaction is highly exothermic, so sulfuric acid fog is formed, which is highly corrosive and that can explode. That is highly exothermic reaction. So that container, even that whole industry can explode, okay, and due to the formation of those fumes, clouds of sulfuric acid, that can harm, means that can cause harm to the people working over there. Okay, that's why first of all SO3 is digested or absorbed in the sulfuric acid. So that leads to the formation of oleum. That leads to the formation of H2S2O7, that is called oleum, and therefore when this oleum is formed, that is transported to anywhere, okay, and that can be diluted according to our need. Which concentration of a sulfuric acid is required, according to that we can add water in it, and therefore we get H2SO4 accordingly. Okay, so these are the steps in the contact process for the formation of sulfuric acid. Okay, so that's all for the day. Thank you so much.